We have spent the last year rolling out tools that generate text and answer questions, but in many offices, the human workload hasn't decreased. It has simply shifted into managing and verifying the AI's output. This is the execution bottleneck. A co-pilot might draft an email or suggest a fix, but a human operator still has to open the necessary software and manually click the buttons to get the work done. So when vendors show up pushing Agentic AI, leaders are understandably skeptical. You are trying to determine if this represents a functional leap in how work gets done, or if it is another layer of marketing hype. Treating agents like simple chatbots limits your ability to scale. Without a clear distinction, enterprises remain trapped in manual execution loops, where highly paid employees act as the bridge between the AI and company core systems. Agentic AI is built to independently execute workflows. It moves the technology out of the chat window and directly into the software that runs the business. This diagram shows the structural difference. On the left, conversational AI waits for a prompt. On the right, Agentic AI operates on a continuous four-step loop: observe, reason, decide, and act. In the observe and reason phases, the agent monitors incoming data streams, like an email inbox or a ticketing system, and organizes the context without needing a human to ask it a question. The agent then chooses an operational path and triggers the command within an external software system, such as a CRM or an ERP. Think of it through an employee analogy. A chatbot is an employee who only answers questions when asked. An agent is an employee who can retrieve their own data, trigger workflows, and escalate complex issues to the right department. This shifts the AI from a passive advisor to an active, autonomous participant in the workflow. Large enterprises are suited for this technology because they rely on thousands of highly repeatable, rules-based decision workflows. We see this in software approvals, complex customer service escalations, and standard exception handling in procurement. We use this enterprise deployment viability chart to map operational impact against governance risk. High-impact, low-risk workflows in the top left, like internal routing, are ideal starting points, but high-risk workflows in the top right, like vendor payments, require severe caution before automating. Value comes from targeting these structured, repeatable paths. Pointing an autonomous agent at random, unstructured tasks simply creates organizational chaos. Let's look at how this functions in IT service management, which is a high-impact, low-risk environment. When a support ticket arrives, the agent reads the text, classifies the issue, and immediately cross-references the internal knowledge base for a solution. It then executes an outcome. It either suggests the fix directed to the user or automatically escalates the ticket to a human technician if the solution isn't found. However, this requires a pristine, updated knowledge base. If your documentation is outdated, the agent will confidently execute the wrong technical fix. Manufacturing provides a more physical example of these agents in action. Here, an agent monitors raw operational signals from machinery to identify patterns that indicate a high risk of downtime before a failure actually occurs. Once a risk is detected, the agent automatically creates a maintenance workflow in the ERP and alerts the engineering teams without waiting for human input. In both IT and manufacturing, the operational value is entirely dependent on the agent's ability to successfully integrate with and trigger legacy systems. We have to address the most dangerous misconception in the market, the idea of magic, instant AI deployment. Giving an autonomous agent write access to core enterprise systems introduces severe risk. If it can update a database, it can also corrupt it. Safely running an agentic system requires strict governance. This scorecard outlines the mandatory requirements for enterprise deployment. First is auditability. For compliance, you must be able to forensically prove exactly why an agent made a specific decision. Second is system access limits. Agents must be cryptographically fenced off to prevent them from accessing unauthorized data lakes or sensitive internal files. Third is clean data. If you deploy an agent on top of messy, siloed legacy information, the AI will simply amplify existing organizational inefficiencies. Most enterprises are forced to complete a significant data cleaning initiative before they are technically ready to deploy an autonomous agent. Without strict auditability and human-in-the-loop controls engineered into the system from day one, autonomous execution introduces unacceptable compliance risks. Full AI autonomy is currently a myth for nearly every organization. Attempting to skip to full independence is a strategic error. The only safe way to scale is through a phased adoption path. This flowchart shows the necessary progression. In Step 1, recommendation mode, the agent observes and reasons, but it can only suggest an action. A human operator must manually click Approve before the workflow can proceed. Once the model proves its accuracy, you move to supervised execution. The agent handles bulk tasks autonomously, while humans are only flagged to monitor exceptions. This phased approach intentionally delays the ultimate financial return on investment. It is a necessary trade-off to ensure risk mitigation. Operational trust must be earned through supervised repetition. It cannot be assumed by default. Operations managers, stop looking for shiny new software. Your priority is mapping your most bottlenecked, repeatable workflows today. If your foundational data architecture isn't clean, you must lock down those systems and fix the data before evaluating any AI solution. CIOs and executives, stop evaluating AI vendors based on how well their systems can converse or write text. You should evaluate them strictly on their workflow execution capabilities and the depth of the governance controls they provide. We are moving into an era where large language models function as active system operators rather than digital pen pals. The goal of this technology is not to replace the business, but to implement controlled autonomy that creates measurable, auditable value. In the next episode, I will break down the top enterprise AI use cases delivering actual ROI today. Subscribe to continue the journey.